Hi, I'm Rebekka.
And my name is Emma, and we will give you a short introduction to circular economy. This is going to be the first video of two, and while this one will talk about circular economy in more broad terms, the second one will push a little bit more hardcore theory and also introduce you to our theoretical framework that you can use as a tool. Well, you may have heard about circular economy in a discussion on how to achieve sustainable development. And no wonder, because circular economy is a trending term. And today, many scholars consider circular economy as a necessary system to achieve sustainability. But what is it really? Well, many think that circular economy is all about recycling, which is also partly true. But circular economy is much more than just recycling. It tries to describe an entire societal system or a way of living and can therefore be used at many different layers and in many different contexts.
And for this reason, the term has also been subject to many different definitions, which has caused quite a lot of confusion for many. But considering the importance of actually choosing one definition when we talk about a term, we have chosen this one by Kircher et al. From 2017, who compared 114 different definitions and then came up with this one as a common one for all of those 114. A circular economy describes an economic system that is based on business models which replace the end-of-life concept with reducing, alternatively reusing, recycling, and recovering materials in production, distribution, and consumption processes, thus operating at the micro level, which could be products, companies, consumers, meso level, which is the industrial level, for example, eco-industrial parks, and macro level, city, regions, nations, and beyond, with the aim to accomplish sustainable development, which implies creating environmental quality, economic prosperity, and social equity to the benefit of current and future generations. But what does this mean in our own words?
Well, circular economy is an alternative to the linear economy. But what does this mean? Well, take this illustration as an example. You can see how the linear economy, represented by the line arrow, takes the resources, make them into a product, use them, and then discard them as waste. In this example, no resources are re-entering the supply chain. And this is how almost all of the products that we use today are treated. The circular economy, on the other side, is represented by the circle arrow. It is depicted here how resources are extracted from non-virgin sources, such as the recycling sector. Afterwards, they are produced and used like in the linear economy, but in this example, they are also reused if possible and then recycled, never discarded. Another relevant thing to introduce you for is the three principles by the Ellen MacArthur Foundation. The Ellen MacArthur Foundation is by far one of the most prominent organizations within circular economy, promoting the concept and implementing it across the world. And they have formulated these three principles. First, design out waste and pollution. Describes a system with zero waste. Waste and pollution is designed out, and waste becomes a resource in itself. This means that no resources at all are disposed of. Number two, keep products and materials in use. We need to create products that can stay in use for as long as possible. We need to pass them on for reuse, be able to repair them, and design them to be durable in the first place. And the last one, number three, regenerate natural systems. Well, with the circular economy comes a raised awareness on how the resources that we use affect the environment, including the biodiversity. We therefore need to be very conscious about what resources we use and how they affect the environment.
But such a system would require a complete reorganization of supply chains, most supply chains as we know them today, which requires new partnerships, new collaborations with common visions. To create a system that lowers the pressure on virgin resources by reusing resources over and over again, and also by looking to alternative sources for resource extraction, Maybe use new technology to erase the need for virgin resources. Imagine if we could pull resources out of thin air. There's actually a company that does this named Fairbricks. Fairbricks make polyester yarn by extracting CO2 from the air, erasing the need for petroleum in polyester production altogether. Obviously, this would also require a completely new supply chain and organization of how we produce polyester and polyester clothing, for example.
With this new supply chain paradigm also comes a system that values local production and thereby also minimizes transport. And lastly, circular supply chains are based on tight collaborations across as well as in between supply chains. First, in the sense that all decisions made at the first step of the supply chain are crucial for the ability to align with the circular economy later down the supply chain. This means that suppliers and buyers need to be in close contact at all times and also need to be aligned on the vision of creating a circular economy. Second, what is considered to be waste in one value chain may be a valuable resource in another value chain. To give an example, we can talk about food waste, for example. Food waste can be used to in many different things, but it can be used to make, for example, a yarn for textile spinning in the textile industry. Also, leather waste that, for example, is too small to be used to make a jacket can be used to make a leather wallet in another supply chain.
In the definition we mentioned earlier, we said that circular economy had the aim to accomplish sustainable development, which implies creating environmental quality, economic prosperity, and social equity to benefit current and future generations. Well, as you might have noticed, we have not talked about economic prosperity or social equity yet, although they're equally as important aspects of sustainability. Circular economy has actually received quite a lot of critique for not focusing enough or dismissing how circular solutions affect the social and economic dimensions of sustainability. We are here to highlight that they are equally as important. It could hence be relevant to look towards other theories or ideas that combine and include social aspects of circular economy, as for example, the donut economy. And speaking of theory, in the next video, we will provide a theoretical framework that is a bit more complicated than what we just went through. We hope that we can here give a better overview of specific actions that are circular and answering questions such as what is more circular, reusing or recycling. Stay tuned as we get a bit more technical, and thank you very much for watching this introduction video to circular economy. See you soon. Welcome back to a short introduction to circular economy. In the previous video, we talked a little bit about circular economy in more general terms. This video aims to go through a little bit of a different theories on circular economy by different scholars. As you can see here, we have chosen to go through close, low, narrow, the R framework, and the butterfly diagram, and then at the end, we want to combine all of them into our own framework that we hope that you can use as a source for inspiration to get a bit more creative in creating circular solutions of your own.
So first we will dive into the theory of close, slow, and narrow. As you can see here, Buchan and colleagues, they have depicted close, slow, and narrow in this figure alongside regeneration. And these four presents the end goal of circular economy, or different strategies that companies they can take on. So in the end, we want to close, slow, and narrow the resource loop, as well as regenerate the environment. So beginning with regenerating, that is concerned with clean production and strengthening the biodiversity, and is therefore depicted with this rather fatter line in the circle, representing like an increased strength in biodiversity. Moving up to narrowing, which is concerned with using as few resources as possible to make as many products as possible. This way we can lower the pressure on virgin materials and narrowing is therefore related to resource efficiency. So therefore, this rather fat line becomes narrower as fewer resources is used to create more products. Then slowing. Slowing is concerned with the extension of a product lifetime and aims to postpone the moment of when a product is considered to be damaged beyond recovery. And slowing is depicted, with these ups and downs that tries to illustrate that the resource flow is slowed down because it takes more time to cross these bumps. And lastly, closing refers to the fact that we need to close the resource flow so that we can create zero waste and pollution. This is also, again, related to the 3 principles of the Ellen MacArthur Foundation that we covered in the first video. So now we will move on to the 9R framework.
Getting into the 9R framework, as you can see here, it tells us how to actually achieve these end goals of close, slow, narrow that Emma just went through. We have many different versions of the R framework. Some are formulated with only 3 Rs, others with 4, and some with 6. But we chose this one with 9 Rs, well, because it's the most comprehensive one. And we like to make things more complicated than they have to be. As you can see here, you have 9 Rs from here all the way in the bottom, R9, recover, all the way to R0, refuse. And if you also look at this arrow right here, you can see that according to this framework, the ones that are on a higher level, for example, R0, is actually more circular than R9, recover, which is quite interesting. Looking into the bottom here, we see that R9 and R8 result in useful application of materials, whilst these here in the middle, R7, repurpose to reuse, actually extend the lifespan of products and its part. And then lastly, the top here, R2, reduce till refuse, results in smarter product use and manufacture. You can pause the video and read the different definitions of the R's here on the screen. What is noticeable here is that a lot of scholars actually say that the ones on the top are more circular than the strategies on the bottom and also require more radical innovation than the ones on the bottom. For example, we have the phone, the smartphone, which went from having, you have one calculator here and then a phone here and then a camera here, which are each of them require different resources, but then in the phone, new radical innovation came and they could all be put into one smaller thing, which required less resources. Of course, here again, you have to use the proper resources for it actually to be circular, but then again, this just shows an example of radical innovation that can reduce, for example, can narrow the resource flow. And that was everything from the 9R framework. And now over to the butterfly diagram.
Yes, now we'll take you through the last theory that we're going to introduce to you in this video, which is the butterfly diagram. And the butterfly diagram looks like this. And it looks rather complicated with a lot of different features, but actually it's very simple what we want you to take from this. First, the fact that the butterfly diagram introduces the division between the biological and the technical loop. As you can see, the biological loop is depicted in green on the left side, while the technical in blue on the right side. And the butterfly diagram states that resources flowing in these two loops should be kept separate at all times, because when mixed, it complicates applying several of the R strategies that Rebekka just took us through, and it becomes complicated to close the loop again. A second thing that we want you to understand from the butterfly diagram is that it introduces biodegradation as a way to close the resource flow. Before, Rebekka, talked about recycling and partly maybe also recover, but now we have a third strategy, and that's biodegradation. So designing a product with only biodegradable nutrients can actually biodegrade at the end of a lifetime. And the third and last thing that the butterfly diagram states that we find important in this context is the fact that a circular economy should always run on renewable energy. And I think that's it for the butterfly diagram, actually. So now Rebekka, she will wrap up and present our framework, which consists of these three theories that we have gone through.
And now heading over to our framework that you can see here, where we have aimed to combine all of the previous theories into one. Here you can see that this model illustrates how each of the R strategies can lead to either closing, slowing, or narrowing the resource flow. So we placed them at different lines here, depending on whether or not we believe they relate to slow, close, or narrow. We have also included biodegradation as a part of close from the butterfly diagram. And we have shown that minimum transport and renewable energy in keeping the technical and biological loops separated is crucial to circular economy. What is very important to highlight here is that you don't have to apply all of these different approaches in one solution. We hope that this can be used as an inspiration for different solutions, some that maybe only focus on repairing and others that have rethink as a main aspect of it. Of course, it's great to combine as many of these as possible to create, if you can say that way, as much circularity as possible, but it's not like one of them is better than the other, although we see that we have more of a circular flow on the right side. Anything is context dependent, and a framework is, of course, a bit too simple to apply into the real world, and we want you to keep that in mind. And we also would like you to keep in mind that we do not include the social aspect or economic aspect of circularity in this model, which are equally as important. So we also ask you to keep in mind that social aspects, what jobs can be created, how solutions affect people that live in the areas where changes happen, how will these changes actually affect the people that live in these areas in the world in general in terms of social sustainability and economic prosperity.
Wrapping up, we want to underline that innovation is absolutely central to circular economy, and that in the future, hopefully, much more will be possible. But really rethinking the way that things are done and the way we use things is a huge part of circular economy. And now you can use our framework to let the creativity flow, because don't let it restrain you. Use it as a point of inspiration, because there are so many different circular solutions out there. So good luck, and thank you for watching our video. Diving a little bit, giving an example of each of these four different end goals, I will start going into an example of slowing. So I will take a point of departure in a t-shirt. So what resources should you use if you want to slow the process in making a t-shirt? Well, you should repurpose existing products and components. And this means that you should use non-virgin resources that have not yet been recycled to create your new t-shirt. Second, you need to create emotional as well as physical durability with the t-shirt. So emotional durability refers to the emotional attachment that a consumer has with the t-shirt or the product. And the more emotional attached the person is, well, the longer the t-shirt will stay in use. And the same goes for physical durability. The more coarse, the more physical durable the product, the idea is that the longer this t-shirt will stay in use. And lastly, we need to design a t-shirt so that it is easy to repair and redesign. Yeah. Moving on to closing here. So, when closing a t-shirt, what kind of resources should you use as input? Well, you should use waste or other recycled materials as input. Because when doing this, you take what is the waste in one resource loop and you manage to close this flow by using it as a resource in your new product. Second, it is absolutely essential that you either use only monomaterials, which is like one material only, or that you make a product that is really easy to disassemble. So you need to create a product that consists of one material only, which is also referred to as monomaterials, or if it consists of more materials, that it is easy to disassemble. Why is this so important? Well, it is extremely important if we look at the fourth point, which says ensure that the product will not end up as waste. Because if you want to recycle or biodegrade a product, it is much easier to do so if a product consists of one material or if it's easy to disassemble. And going back to the third point, zero impact during use is also important. All products, they shed these different microfibers when used, especially a t-shirt that, for example, is made out of polyester yarn. And these microfibers, when they are shed, they will not biodegrade. So one thing that you should have in mind is to create products that consist or that are made out of materials that can biodegrade. Because when they can biodegrade, they will disappear and they will help you close the loop. But when they do not biodegrade, well, they will pollute the environment, and you will not manage to have control of the resources in the resource loop. Then moving on to the third one, narrowing a t-shirt. So what resources should you use when designing a t-shirt and you want to narrow the flow? You should design a t-shirt with low impact resources. These are the kind of resources that need little land, little water, etc. to grow. Second, innovation is central in narrowing the flow. There are examples of companies that make resources out of only a few stem cells in laboratories and then grow, duplicate the amounts. Third, you need to maximize the capacity of the t-shirt. And this is related to different business models such as rental or sharing, because when more people can access, for example, a t-shirt, well, then you will have to produce fewer t-shirts, and thereby you narrow the flow. And lastly, you need to design a lightweight product, because lightweight products, they require less energy in the transportation, and maybe also they can be stacked easier so that the more products can fit. And lastly, regenerates. Well, if you want to regenerate the environment and comply with this fourth strategy or fourth end goal of circular economy, well, then you need to design with renewable and regenerating materials and design with the non-toxic materials. That was all from Close, Slow, Narrow.